All right, are we live? Are we here? Hello, 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 hello. I think so. I think we're in good shape. Make sure I don't have anything incriminating on my computer here before we begin. So, good morning. I just wanted to go ahead and kind of get back to what we were doing. Just keep working on problems. Keep going. So this problem today is find the duplicate number, and I think this is going to be similar to one of the problems we've already solved. Actually, this might be very quick. Let's see how it goes. So, given an array of integers nums containing n plus 1 integers where each integer is in the range 1 to n inclusive, there's only one repeated number in nums. Find this repeated number. No. This is a problem we've already seen. This is a very interesting problem. So, how you solve this problem? I've seen this before, so I know the answer. But basically, it's kind of neat. What you're going to do is you're going to move every integer, swap it with its respective position, put it in the right spot, and what's going to happen is you're going to swap the duplicated number. You're going to end up trying to swap it with itself. So I'll show you how this works. And we're going to actually modify this vector as we go. So I hope this makes sense. Yeah, I hope this makes sense. I think it's the way you do it. And then we're going to say, so the thing that's interesting is, the reason why this works, by the way, is the integers are n plus 1, where each integer is in this range. Oh, actually, the index is going to be subtract 1 for the index. But what's going to happen? So you've got this. So you look at 1, right? And then you say, okay, the index for 1 should be 0. That's the position it's supposed to be in. We say if x minus 1 is not equal to I, then there's actually two things you want to do. If it's already in the right position, we don't touch it, right? So 1 is in the right spot already. 3 should be 1, 2, 3, position 2, right? X minus 1 should be the correct right position. If it's not already there, you put it there, right? Oh, you know what? I made a mistake, actually. It's not this easy. Thought it was this easy, but it's not. Yeah, I guess the issue you run into is basically what you're going to do is you're going to follow. I forget how to. I'm sorry. It goes like this. It goes like this. Because all these numbers are in this range, you could put all the numbers into their correct positions, and then you would have the two repeating numbers would overlap with each other, and then you would know that which one is repeating. There's a few ways to do that, I believe. I think the simplest thing is really put them in the right place. The problem though is, so if you put 3 goes here to 4, you actually you kind of want to do a while loop here, really. I think that's probably what you want to do. While x minus 1 is not equal to I, right? Or better, nums of I is not minus 1 is not equal to I. Do it this way. What you're going to do is you're going to swap, and let's just do int check is going to be equal to nums of I minus 1. What you want to do is keep swapping this number with the correct position. So 1, it's equal to itself, right? 0, 1's in the right spot. 3 is not in the right spot. You put 3, it should be 0, 1, 2. So it's not in the right spot. 3 minus 1 is not 1. So you put it in 2. And you swap it with 4. But then 4 is not in the right spot. 3 is in the right spot, but 4 is not. So you swap 4 with 2, which gives you, right, 0, 1, 2, 3 would be the right spot. You swap with 4 with 2. And then 2 is in the correct spot. So then it would move on to 3, check 3 again, check 4 again, and then you see 2. Now the tricky thing here is you would want to swap 2 with 0, 1, 0, 1, right? However, if what's already there is equal to what your if it's equal, then you're done. Otherwise keep swapping. So it's going to be nums of I. It's going to get swapped with nums of I minus 1. I realize it's a little confusing, but that's effectively what we want to do. Something like this. Yeah. It has to do with there's another way of doing this too, which has to do with like without destroying this array, but it has to do with the fact that these indices map very nicely to the actual array positions. Let's throw in these other cases. That should do it. I was saying I thought this was going to be kind of quick, but it's not that quick. Can we solve this without modifying? How can we prove that at least one duplicate must exist? So you can prove it must exist because there's n plus 1. It's pigeonhole principle, right? You've got 1 to n inclusive, but you have n plus 1 integers. That means one of these has to be repeated. Yeah, you can do it without modifying the array. I forgot. That's actually what I'll look at now. Can you solve using only constant space? Yes. Solve this with less than O(n) squared. Yeah. So this is linear time. This one. Every time you call the swap, each position goes into the correct position. So you're not going to end up iterating more than you're not going to iterate too many times here. I want to say it's like sort of O of 2n, which is O of n. So this is linear time. The only thing we didn't get here is one piece, which is without modifying the array. Let's see, are we correct though? Let's try it. Let's go for it. There we go. Okay, so we got it, but we didn't fully answer the question yet. Right, pretty fast and pretty good memory, but usage of memory. But we actually can do better than that. Instead of excuse me, instead of swapping the numbers, you can actually what do you call it? You can actually jump to the position itself. So from 1, it's kind of interesting. It's a cycle. It creates a cycle. So there's some point in the cycle. It's a really nifty kind of approach to this problem. Really interesting. But basically, you can create a cycle, and then you can find the cycle, and then the index of the cycle you can use to find the value. It's very there's like a lot of pieces involved, but I'll explain. So what you do is if you take this value, the index is supposed to be at is 0, so it cycles back to itself, so it's fine. So you would skip all the numbers where they're already in the correct positions, right? You wouldn't worry about that. But let's say you go to 3, that's supposed to be at index 2, and there's a 4 there. That's supposed to be at index 3, and there's a 2 there. This is supposed to be at index 1, and there's a 3 there. Now you create this cycle, right? Now, so you end up 3, 4, 2, this is 1, 2, 3, right? 3, 4, and then back to 3. This also will enter the cycle. I want to say you can break the array up into cycles. Just thinking, there's another way to do this, right? 0, 1, 2. This 3 goes to 3. Actually, that's it. That's it immediately. So you're just done there. But I want to take like another example. Like throw in some more numbers. 1, 2, 3, 4, 5, 6. Yeah, let's do it that way. Let's do like 5, 1, 2, or 6, 5, 1, 1, something like this, right? This is wrong. 1, 2, 3, 4. So you go 0, 1, 2, 3, 4, 5. This is where it's supposed to be. Or 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, 7. Did I do something wrong here? Oh yeah. Okay, sorry. Yeah. So this 6 would be at index 5. 0, 1, 2, 3, 4, 5. Right? Zero, 1, 2, 3, 4, 5. The 5 there would go here. And this 1 would go back to the 6. And so you have this cycle. 6, 5, 1, 6, 5, 1. So I have this cycle. You also have another cycle here, right? 3, 4, 2. And then you have one value that's sort of out of place. I wanted to say something about these cycles. Basically, somewhere in the cycle you'll find the you'll find the duplicate number. You'll find the duplicate number before coming back to the beginning. That's what I want to say. In other words, this creates a cycle, but then this actually jumps into the cycle. and you never come back, I guess, something like that. That's kind of what I want to say. I want to say something like that. Like every number is part of some cycle, and only the duplicate number will not bring you back to the to itself, right? In other words, it'll be sort of like the first element in the beginning of the first element, and then jump into into a cycle. But it won't come back to itself. It'll come back to, it won't come back to that index. It'll come back to, you'll see it again, but you won't see it. I want to say, you could even do it more easily than that, because we're trying not to use extra memory. So what I want to say is, like, the next time you see that number, so you're going to loop through the cycle, and the next time you see that number, if it doesn't have the same index, that means it's the duplicate. But there's a problem with that, though, right? Because technically the cycle could be the whole thing, and or you could break this up into small cycles where each number has to go through a cycle, and then the next number in that cycle goes through the cycle again. In other words, if like the cycles are roughly half the, like there's a really large array and each cycle is roughly half the array, then half the elements are going to do n over 2 elements are going to do n over 2 time, which is actually quadratic time complexity. So we do want to do better than that somehow. Basically, we don't want to enter into the cycles more than once. That's the tricky part. Without modifying the array is kind of tricky. I want to try to do these at the same time without modifying the array and only using constant extra space. How do you do that? How do you do that? Because this obviously modifies the array. It doesn't use extra space, but modifies the array. The cycling is basically what you want to focus on. That's kind of a challenge, trying to figure out how to do this without doing it in linear time, but without using extra space, without modifying the array, not using extra space, and doing it in linear time. That's tricky. Already 20 minutes in here. We probably want to think about excuse me. I'm just thinking, how do we not enter the same loops over and over again? That's the tricky part, tricky thing. By the way, another way to solve this, if you can change the array in n log n time, is just sort the array, and you can quickly find the duplicate, the one that shows up repeated. Or you can do a hash on, frequency map, also to find out which one is the frequency map. Uses memory, but it's also a linear time. But there's a way to do this in linear time without destroying the array, without using extra memory, I do believe. However, I'm struggling to ascertain which one, which element, how do we do that? How do we do that? No matter how this is put together, there is going to be a cycle, at least one. Yes, that's true. What if we put every number, what if we consider every number to be not at the index that we want it to be at, but all the indices to the right, if that makes sense, right? So in other words, 6 goes to index 6, right? Because it'll exist for all of them. So 6 goes to index 6, 1 goes to index 1, 3 goes to index 0, 1, 2, 3. 2 goes to index 2, 0, 1, 2, that's index 2. 4 goes to index 4, which is 0, 1, 2, 3, 4. And then 1 goes back to index 1. And the cycle continues, right? Oh, now that's really interesting. Okay, so I think if we interpret every number not as the index that we would like to put it at, but as its actual value, as the value as its index. So we're going to put every number, we're going to fit all n plus 1 numbers into n slots, basically. Then we not only do we guarantee a cycle, but we know also the cycle is going to include every number. That's what we got to do. That's what we got to do. Okay, that's very clever and very subtle. Very nuanced, subtle kind of a thing. But basically, if we force all the numbers into the same range, then one number is going to show up twice. And not only that, but because all the numbers don't fit, and they're all unique except for one of them, they're all going to basically connect to each other to create a cycle. And there's going to be one extra number somewhere in there where it's basically the beginning of the cycle, and then somewhere in there the numbers begin to cycle with each other. And I think you can guarantee there's only going to be exactly one cycle. Now that's a tricky thing. Is it possible for, like, if you did just 1, 2, 3, 4, 5, 6, right? 6 would go to 6. So I think it's actually, I'm not sure. No, I'm not sure now. I don't know. If you had 1, 2, 3, 4, 5, 6, right? Had those numbers like that. This first 6 would put you at 6, and then 6 would cycle back to 6, and actually you would be able to find the duplicate that way, almost immediately. What if you did this, right? So you have, let's say 1 is here, and 3's got to be somewhere. It's got to be 1, 2, 3, and then 2's got to be there, and then 4's got to be here. Okay, let's do it this way. So we go here, we go right into 6. 6 goes to 1, and then 1 starts to cycle. Oh no. Yeah, 1 and 1 cycles with itself. You go 6, 1, and then 1 cycles with itself. Is the beginning of the cycle always the number? I don't know. Like the first element in the cycle. I don't know. But if you put a 6 here, only element you have left is a 1, and then you would go 1, 1, and then 1 is the duplicate number. I really don't know, man. I kind of want to I don't have a proof, like an obvious proof as to why that would work. Like if you just had some of these numbers in the right spots, you can kind of pick whatever number you want for this. But if you had just some of these numbers in the right spot, so let's do. The thing is, if you put a number in the correct spot, it actually has to move another number out of the right spot, because it's how tightly wound up this is, how tight the bounds are. Really, really interesting problem. Really fun problem. I've seen this like I mentioned, I've seen this a few times. Did not come up with this on my own. The solution, definitely not. But let's just put like let's put 2, 4, and 6 in the correct spots, but we'll do 5, 3, and 1 in the wrong spots, or 5, 1, and 3 in the wrong spots. And then we can do whatever we want with this. We just do like 3, right? So 3, we go to 1, 0, 1, 2, 3. That goes to 1. 5 goes to 0, 1, 2, 3, 4, 5, which then goes to 3, which is I think here. 0, 1, 2, 3. And the cycle continues, right? So we get 1, 1. So we get 3. 0, 1, 2, 3. Oh, wait. 0, 1, 2, 3. That goes to 4. Goes back to 3. Interesting. So it goes back to 4 and back to 3. I want to say that the duplicated value is always going to be the head of that cycle. Like the first node in the beginning of the cycle. And then also obviously there's more than one cycle here, right? Oh no. That's the only one that'll create a cycle also. Because the other numbers Yeah, I guess you have to start with this number because you're never going to touch it otherwise. All the other numbers, because they're unique, they're just going to push you to some other part of this array. It's only the duplicated number that can even cause a cycle. So if you I mean, obviously you kind of have to start here, otherwise you won't include it. You'll never touch it. But if you started somewhere else, that cycle will eventually get you back to. You'll actually just cycle through all these numbers over and over again, right? If you start anywhere here, that doesn't include the any number that you touch that doesn't include the duplicate, it's just going to cycle through everything. So basically, the duplicate, does it have to be? No, it doesn't have to be here. You just have to touch this one because, yeah, okay, it's. Realize it's confusing. What if the duplicate's not here? Well, this kind of has to be the duplicated number. In this scheme. Is that right? Let's make this 6. And then make this 3. What happens if we do that? Right? Like, how does that, why? I don't know if it makes any sense here. So 6 goes to 3, 3 goes to 0, 1, 2, 3 goes to 4, 4 goes to 3, 3 goes back to 3, 4 goes back to 3. It doesn't matter. It doesn't matter. There's some cycle involving your duplicate value. And whatever number you pick, it really doesn't matter what number you start with, I think. If you go 5, you go 0, 1, 2, 3, 4, 5, you go to 3. That goes to 0, 1, 2, 3. Oh, I'm sorry, I got this wrong before. 6 goes to 3. 3 goes 0, 1, 2, 3 goes to 1. This goes to 0, 1, goes to 5, which goes to 0, 1, 2, 3, 4, 5. Then goes to 3 again, 0, 1, 2, 3. Which then goes to 5, which goes to 3, goes to 1, to 5, to 3. Why is it that six goes to 3, which goes to 0, 1, 2, 3, so 3 to 1 to 5, 3 to 1 to 5 to 3. It's actually got to be. It's got to be the node just before the head, I guess, if that makes sense. Like right before you enter the cycle. Because what's going to happen is that there's a cycle, and there's a node where you enter into the cycle, and the number that takes you to that node, which is x, it's going to be the x right before, and the x that jumps in. And those are duplicated, right? Those got to be the same values. Basically, another way to think about it is there are 6. I know what to do. Okay, here's how you do it. There are n nodes. Let's say there's 5 of them. And if every node points to some other node, right? There's actually, we'll do it this way. There's 4, so we're between 1 and 4, but we've got 5 nodes. All of these nodes point to one other node, but one node doesn't have anything pointing to it. No, every node points to another node. No, wait. Since you're between 1 and 4, there's one node that you're not going to point to. That's what I want to say. Let's do it this way. So Okay, that's the way to understand it. You're between 1 and 4. Nobody's pointing to this fifth node, but there's one node that has two things pointing to it. So every node has at least one pointer pointing to it, except this one has no node pointing in, nothing pointing in, and it's got one pointing out somewhere, and these all have one pointing out, which means that some node has two pointing in. That's what we want. That's the key. So the node that has two pointing in, that's going to be the entry point of the cycle, because this is going to create a cycle, right? These nodes pointing to other nodes creates a cycle, right? Now the duplicated node is exactly because the nodes, we're going to label the nodes as literally being the values themselves. We don't really care about the duplicated node, we just care about the index that it's pointing to. So this index is the one where it has two pointers coming into it. So it's just before the entry point of the cycle. It's just before the entry point of the cycle. So you actually what you do is you can use the tortoise and the hare cycle detection, right? One pointer moves 2 spaces while the other one moves 1. Eventually they're going to collide. And the pointer that, and you're also just going to keep track of just before the node just before, and that should do it. Which actually, yeah, the node just before, and hopping from one next node is literally just, you have some value, and then the array value at that index, take that value, consider an index in the array, that gives you your next number, the next node. Yeah, kind of interesting. Hopefully that makes sense. Hopefully I'm able to articulate that. So it should actually work. Basically, it doesn't matter where you pick, as long as you've got to get into the cycle somehow. And now here's the thing. You want to start with a value that's, you actually want to start, because you're looping between 1 to 4 or what have you. You kind of want to start outside of it. Now that node can't have anything pointing to it. That has to be one of these guys. Is that right? 6, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. It has to be one of the duplicated node, pointing to one of the duplicated nodes. I don't know. Could we put 3 here and 2 over there? 0, 0, 1, 2, and then 3 goes to 0, 1, 2, 3, and that goes to 0, 1. What does this look like? I'm trying to understand this, test the theory out. I don't know if this makes sense. So here you would have 1, 2, 3. You have 1, 2, 3, 4, 5, 6, 7. Yeah, you have six different. You have 7 nodes, but 6 different indices. 1, 2, 3, 4, 5, 6, 7, and 6 is this guy. No. So it gets really confusing too, because it's actually more like this, right? The 1 through 6 is over here, and this is the 0. And nothing's going to point to 0. So this 6 points over here, then this 5 points to 1, 2, 3, 4, 5, and then this 3, 0, 1, 2, 3 point, or I don't know, this guy points to 3. 1 is 1, 2, 0, 1, 2, 3. You kind of want to do also, let's go like this. 6, 5, keep the pointers that are going in on the bottom, and the pointers going out on top. 3, 0, 1, 2, 3. 0, 1, 0, 1. This is the third one. 0, 1. The fourth one is 4, 0, 1, 2, 3, 4. And I think that's pointing to itself, I want to say. Is that right? 0, 1, 2, 3, 4. That's the, yeah, okay. And then this is 3 again. 0, 1, 2, 3. So this is going to point back to 3. And then finally, this last one points to 2. 0, 1, 2. Across all these lines. Okay. So, yeah, I mean, this one will never have anything pointing to it, right? So it's always kind of on the outside, the way that we've set this up. So you kind of always start here. Basically, you can always start there. That's kind of what I was trying to get at, because none of these are going to point to 0. So then if we trace this, we get initially this node, which then comes back here, here, here. Boom, this is going to be the one that we want. And the cycle is going to be here, here. Kind of hard to follow, but we got it. Here and here. That's the cycle. And now what's interesting is it's actually just before the cycle begins, which is this one, and it's the other one, this one, and the other guy, this one that points to it. Yeah, so these two. So I mean, there's a few ways to think about it. You can literally take, well, because the index is the same thing as the node, the index is the same thing as the node that we're looking for, something like that. It's going to be 3, right? Like in other words, 3 both end up pointing to this spot, which is 0, 1, 2, 3, the third index, but they're both 3s, I guess. Like that's, yeah, the nature of it. So those are just both the indices. So you don't actually really need to, like, you don't need to keep track of the indices of these things. What pointed to those 3, those spots, those 3s, which were, what is this? This is all the way on the right side. You don't need 6 to know where 3 is, and you don't need the other one, which is 5, to know where 3 is, or you just have 3 in for both of those. So pretty interesting, really interesting problem. Yeah, this is super neat. Duplicate. Find the duplicate number, 287. Like I said, I've seen this problem before. This is like pretty, even though I've seen it before, I've seen it a few times now. Obviously, it still kind of like jars me a little bit when I try to come back to the solution, knowing the solution, remembering the solution. So I'm actually gonna do something kind of nifty. So we have fast, slow is going to be, fast is going to be nums of 0. Slow is going to be nums of 0. And you're going to, while fast is not equal to slow, I think you literally just return these two. Fast is going to be equal to, you're going to do it twice, so you're going to say fast is equal to nums of fast of nums of fast. And slow is going to be nums of slow. Well, they're not equal, don't return anything. And then once they're equal, return fast. Wrong answer. Nice. Okay. So 1, 3, 4, 2, 2. What do we got? We got fast. They both start at the same spot. You say it may even be something like I could be wrong. Maybe it's like there's a difference between these two. I'm not sure. I gotta think about it. Hold on. So start off at 1. They go 0, 1. So they go to 3. Fast goes to 0, 1, 2, 3. So fast goes to 2. Slow goes to 3. Fast goes to 0, 1, 2 goes to 4, which then goes to 0, 1, 2, 3, 4. Which then goes back to 2. So fast goes back to 2 here. Slow goes to wait, this is so confusing. How does this loop ever break if these aren't? Is it? Am I crazy? Wait a minute, what? Hold on. That's really confusing. If they're pointing to the same thing, oh, because as soon as you enter, oh, that's why. Oh, okay, of course. Duh. That's my mistake. I was like, wait a minute, why is this? Okay. What is going on? What? Whoa. It works for these other cases, but it doesn't work for this one. Why? What am I doing wrong here? Wait a second. All right. Starts off at. Am I crazy? 1. Slow is 1. Fast is 3. Slow goes to 3. While fast jumps ahead 2 to 0, 1, 2, 3 goes to 2, and then goes to 0, 1, 2 back to 3. So 3 goes to 2 back to 3. So 0, 1, 2, 3, and that 2 goes back to 3, 3, 2, 2, 3, back and forth all this way. No, 0, 1, 2, 3, 0, 1, 2. I'm sorry, it goes to 4. It's kind of hard. I'm trying to struggling here. 1 goes to. I think I have to just draw this out. That's too much. Hold on. Oh boy. Oh boy. It's very close, but it's not quite. Not quite. Almost. Almost. All right. Let's just take a look at this test case. So. 1, 3, 4, 2, 2. Okay, 1, 1, 3, 4, 2, 2. It's got these nodes. 1, 2, 3, 4. 1 goes to 1, 1, 2, 1, 2, 3. This one goes to 4, and 2 goes to 2. 0, 1, 2, 2. Okay. Fair enough, right? Fair enough. So this cycle should be this guy to this guy to this guy, and the cycle's here. This one, right? And the number is this guy who enters here, and this guy who enters here. So I want to say something like, you could do something like this. I want to say something like this. You just say when nums of fast equals nums is equal to not equal to nums of slow. And then yeah, and then just return one of these. Something like this? I don't know. Am I crazy? Am I just going nuts here? What am I missing? Why doesn't this work? Why is this not working? That's definitely the right loop. When they're equal to each other, when this condition, so we start off, we'll do F and S. Start off here. Fast, we're just gonna 1, 2, 1, 2. This is F. F, -1 rather. And F0 initially. S1 or S0. 1, 2. That's F1. S1. 1, 2, F2. All right, jumps here to here, right? S1, S2, and finally F2, F1, 2, F3, and then S3. Boom. All right. So they're equal. Okay. Now, oops. Problem with that is where they meet actually makes it look like this is the beginning of the cycle. This guy. And this guy is really 4 or 2, depending on how you look at it. It's index 4, and then the evaluate there is 2, which is what we want. We actually want the 2. The 2. No, it's not the 2. It's oh yeah, no, that's actually that is what we want. Right? 0, 1, 2. 2, 4. What do we get? 2. Yeah, that's what we expect. Okay. Oh, so that one's not the problem. It's the second one that's the problem. Okay, so, all right. 6, 5, 3, 1, 4, 3, 2. obviously is not ideal to be kind of hung up on this. Why are we getting stuck? But okay. 6531432. 6531432. What's going wrong? We go to 6 over here, 5 over here, 3, 1, 2, 3, 1, 4, 3. I think it might be because of the 4, and then 2. Now obviously the nodes that are in the correct position, we can skip those, I guess. I don't know. Excuse me. So what we say is 6, 2, 3, 1, 5, 3. This one. And this one. Oh, no. I'm sorry. Uh-oh. Whoa. Why is this going to 3? 1, 2, 3. Wrong. This one does go to 2, though. And this 3 now goes to 1, 2, 3. So then goes to 1. Then goes to 5. This goes back to 1, 2, 3. This goes back to 1. Oh. Whoa. Excuse me. This goes to 2, which then goes to 1, 2, 3. Then goes to 1. Then goes to 5. Then goes to 3. Looks like a heart. Then goes to 1. Then goes to 5. Then goes to 3. And you never get back to 3 again, do you? But you do. You do have this 3 that enters in here, into the loop. But somehow we don't get 3. Yeah. Okay. Right, well 1 is the entry point to the loop. Okay, now that makes sense. Huh. Well, yeah, so you do want the previous value. I mean, alright. You know. Something like this. Still wrong. Come on, really? is this? What? Wait a minute, what? I'm so confused. We need to add more test cases, I think. Well, no, I think the logic is just wrong, right? Brother. What is going on here? You do while also. I don't use that too often. I don't use that too often. How? I don't know. Okay, all right. I don't. Something funky's going on here. I'm missing something. We don't need to make it a do while loop either. I don't think that's really necessary. Also interesting that the what what? Hold on. This is so weird because if they're not equal and then you update them to these values and then now they're equal, that means that slow and nums of slow, that means that nums of slow must be the duplicate number, right? Because these are two different positions. Unless they're now pointing to the same position, which is no, they are pointing to the same. Oh man. Okay. I think I see the problem. I'm starting to see the problem. There's some confusion between the duplicate number and the duplicate index, if that makes sense. And that gets very confusing indeed. Oh boy. Man. Oh man. There's also this issue of like, yeah, this. If you just happen to somehow hit this 4. I don't think that's a problem. The only time this is a problem is if 0 itself is like. But no, this doesn't point. This will never point to 0, so you don't have to worry about it at all, I think. Why? What is going on? Why is this one? Is it this one that's wrong? Which one's wrong? 2 3 3 1 1. We get 4 3 2 1 1. What? What? It's very funny. 2, so we get the right answer here, and then the next one, we get output of 2 and expected 3 on the second one. Output 2, expected 3. Why do we get output of 2? What are these equal to when this happens? What's going on here? Okay. So slow in the second case was 3. 0, 1, 2, 3. So, excuse me. Yeah, that's what we expect. We expect this to hit here. But now the confusing part is previous should be 3, right? The only way to get to 1 is from 3. So how is previous 2? 0, 1, 2. Output 2. We can just do this. Just trace the whole thing out as we go. What the heck is going on? What is going on? All right. See what we get. What does this look like? Is it what we expect? And why is it different? I'm super confused. I definitely made some kind of stupid error or something. I don't know. Something's got to be wrong here. All right. Can we? Hold on, I'm struggling here. All right, what we're gonna do? Take this output, save it, put that into another document, and now do it that way. Okay, here's the picture. Here's our document. There we go, that's a lot better. All right, now. Okay. Slow is 6, fast is 2, right? No, fast is not 2. Why is fast 2? Fast should be, oh, that's probably why. Okay, I think I understand now. Because I'm kind of a dummy, that's why. Yeah. Got it. That might have something to do with it. So I'm kind of a dummy. Wrong answer. Nice. There we go. That's why. Because I thought about it too a bunch of times, and I was like, so the fast one moves 2 and the slow one moves 1. So the fast one should start off at 2 iterations and the slow one should start off at 1 iteration. That's incorrect. They start over the same point and the fast one gets moved forward and the slow one gets moved. Yeah, and you probably want to even go like this. I think I'm still wrong anyway. Or apparently I'm still wrong anyway about this one. Nice. Okay. Great. How did... What? Am I still wrong on this? What is even going on? Am I just nuts? I think I might just be crazy. What is going on? Start them at the same point. Increment 1 by 1, the other one by 2. Keep the previous value. Should return the previous value once they're equal to each other. But this is wrong. It's actually wrong. Yeah, 6531. Why? Oh man. Why? Why? Okay. Morning. What's up, Simon Steinen? Hope your day's going well. Welcome. You caught me at an awkward time. Caught me at a time where let's see, how long are we on this? An hour I've been on this trying to figure out this problem. Not even figure out the problem. I'm pretty sure I have the solution, but I think I keep coding it wrong. And I don't know what I'm doing wrong. It's like really silly. I'll explain in a second. I'll need to see if I can figure out what's wrong before I explain it, though. Hopefully I can figure it out. Hopefully. Oh, that's a lot of output, huh? Okay. Oh, that's a lot of output. Nope. No. Oh, that's why, because I don't... Yeah, okay. I want this one. You don't need that much output. Too much output. Alright. Okay. Okay, so we initialize them both. Did you leave Twitch for good? I did. Yeah, I did. Supposed to leave YouTube too, but I don't really have a good spot to stream on. I'm probably gonna, I don't know. I'm trying to avoid the bigger tech companies because they're extremely, there's a lot of things they're doing that I don't want to support. I feel like I'm actually committing sins by like directly supporting organizations that are like not very neutral when it comes to certain things. And like it's fine like if you're dealing with a company that like you don't really know that they're doing the wrong things, or it's like it's not they're like relatively neutral. Like they'll do evil things, but also do good things. Like, but they don't deliberately do evil things. If that makes sense. But when you know that a company is like very directly supporting something that's evil, uh, yeah, or like I don't know, like propagating lies to the masses, like deliberately, something like that. Like if it's like very obvious, then I think it's like, all right, that borders on like sin to continue to support that company. But I don't know where else to go now. Like I don't know what I'm supposed to do. Like I'm kind of stuck. Like I'm using YouTube, and I'm very conflicted about it. But anyway, yeah, I wanted, yeah. So I left Twitch. They're owned by Amazon. Don't have anything to do with Amazon. That's relatively easy for me to break away from. But YouTube, on the other hand, they're affiliated with Google. Trying to break away from Google, that's a lot harder. I have an Android phone. I have to go find, basically try to get a phone that's not Android or Apple. Maybe just get a flip phone or something. I don't know. Try to get off of the phone. Have to get off the phone. Have to get off of Microsoft. have to get off of. Have to get off of. Yeah, I have to get off of YouTube. It's hard, man. It's hard. I don't know what to do. I'm just gonna leave it for the time being. I think eventually I'll figure it out. But yeah, that's basically. I haven't really explained why these companies need to be avoided, but we'll just say it's a long story, and they're just doing a lot of evil things that I can't support that as a Christian. I don't believe I could support it conscionably, Also, hopefully the noise you're about to hear isn't too bad. I'm gonna charge the headset here. Yeah, I'm sorry about that noise. That's charging. That's what's going on. It creates noise. Yeah, left Twitch, not coming back. It's trying to get off. Like I said, trying to get off of YouTube too, but I don't know where to go. Assume big streaming goes with big companies. Didn't want to get you into a crisis though. Doesn't make sense for me to keep following on a dead account. I appreciate that. Thanks. Yeah, no, I think it's. I mean, I was actually going to delete the account at some point. Or I intend to delete it. Intended to delete the account. Because it's. I don't want, like I said, I don't want to have anything to do with Amazon anymore. Yeah, I realize some folks who they appreciate my streams, they want to watch. They're probably not too. Probably an unpleasant surprise. So I'm sorry for that. I kind of did say for a while that I was gonna get off of Twitch, but I've been kind of back and forth about it for a while, because I don't know, I kind of really haven't found. Well, there's a lot of things. It's I haven't really found a comfortable spot that I'll really place I want to stream, and I don't make money streaming, which I'm not complaining about it. I'm just saying that I have other priorities in my life, I guess, and so I really don't. It's almost like not that I don't care about streaming. It's I kind of can't. I have to care about other things more. If that makes sense, because I got bills to pay. a lot of bills. I'm pretty upset lately because I realized that I lost so much money in the market that if I just hadn't put any in the beginning, I actually would have paid off all my bills right now, which is really upsetting because I don't know. It's I started off I just want to invest my money because it's just sitting there, and then I did really well, and then I've come to find that a bunch of people deliberately crashed the market, and then it knocked me off of what I was doing, and I tried a bunch of other stuff, and those things didn't go well because they kept cheating. Same people kept cheating. So when the market was supposed to be fine, it crashed, and then when it was supposed to be crashing, it was exploding, going upwards. It's I'm just in freaking I'm in this clown world in terms of financially. It's it's driving me crazy. That's a completely different story though. That's kind of unrelated, but it's somewhat related because, like, I don't know, I was doing really, really well. I was doing really well, trading stocks, but then a whole bunch of hoopla happened, and now I'm like, I don't even know what to think anymore. I don't know. Anyway, that's, yeah, totally different story. But that doesn't help the financial aspect of things. That's the point. The reason I brought that up is, like, aside from being, I mean, it's just upsetting. It's actually just really upsetting, because it's a lot of time. Lost a lot of time. But I suffered through that too. Those years that making that money, I suffered through a lot of that. But I mean, I'll be fine. I mean, there's nothing. I'm financially, I'm great. It's just the problem is time, right? Like now I'm set back like years, and I would have been. I'm trying to catch up in the years. Like, that's the whole thing. The whole reason I even tried that is because I feel like I've been set back so many years. It's just not fun to think about. It makes it a little crazy if you think about it too much. But regardless, I don't really have that much. Like, I in theory don't have a lot of time to like just stream on Twitch, I guess. Like, I don't know. Technically, what I'm doing now is like wasting time, but not really. I don't know. I'm conflicted about that too. I'm like, this is supposed to be like preparing for interviews, but again, I'm like not even sure what I want to do in the future. Like, I don't know if I want to keep my job. I don't know if I want to go find another job. It's all not very fun to think about. It's all, yeah, very grim. All of the prospects and the thoughts I've been having lately, very grim. But anyway, sorry, I don't have to get into that. Don't have to get into all that. We'll just say I'm not on Twitch, and I don't want to support Amazon at all. What they're doing, and I could very clearly see that they're engaged in pretty evil things. And then Google, same deal. Google probably even more so. I forgot exactly why Amazon's so bad. I think the reason that Amazon is so bad. Oh, yeah, because the propaganda. Yeah, that's why. Yeah, the propaganda pushing. Microsoft, Amazon, Google, all the big companies. The thing that's sad about it too is, like, all of these companies they're kind of like inevitably going to be like really evil because they're of the world, if that makes sense. The deal with Christians is like there's things of the world and there's things that are Christian, and these companies are decidedly not Christian. And the reason why big things will sort of always be evil is, according to the Bible, a person's heart it's not just evil, but it's unfathomably evil. Like, you can't even understand how evil a person is. That's everybody's like that. So if you have high concentrations of people, that's high concentrations of evil. Whereas if you have small numbers of people, small amounts of people, then the evil is a lot more mitigated. Because it's just, well, for starters, you have the potential for Christians to be there. So if there's like not that many people and a good number of them are Christians, you have a lot less evil. But once you start getting into situations where there are not that many Christians and there are a lot of other people, that are not, then you get into a situation where that whatever that entity is, whether it be a city or an organization or whatever it is, if it has a lot of people, there's a whole lot of evil going on there. So that's kind of goes hand in hand with it, I guess. That goes it's partially the thing. Oh, I remember now. This is why I don't want to have anything to do with Amazon. Slave labor. That's why. Chinese slave labor. I completely forgot. Most of the trinkets and gadgets and gizmos and all this junk that's bought and produced and sold on Amazon and from Apple and Microsoft, all this stuff. Although Microsoft's kind of different reasons, but all this junk that we buy, it's all made. Most of it is made with like slave labor from the Chinese. All these different pieces, all these things that we see that are made in China. I've heard, I don't know, I kind of have to double check because I've heard something about a lot of things being made in Taiwan, which is I think fine because they're it's technically not slave labor over there, but I don't actually know. Probably not. I mean, probably anything made in China is made through a pretty evil way, pretty corrupt way, and it's kind of yeah, I can't support that, you know. So that's why, right? That's why no Amazon, right? I forgot. I was like, why not Amazon? Oh, because all these products that you're buying are made by slaves. It's like, oh, right. that would make sense. Yeah. So anyway, back to the problem. So we start off at zeros. Then we go fast, slow, previous. So fast shouldn't go to 2. Should go to 0, 1, 2. It should actually go. I think the problem might be that these are supposed to start off at this position. And yeah, something like that might be the problem. Oh, that was the problem. Or at least in this case. What about these other cases? No. Okay, it's wrong in the other cases. Okay. The first one now is wrong. Okay. Okay. All right. So first one's this one over here. One, 3, 4, 2, 2. 1, 3, 4, 2, 2. So 1, 1, 1, 2, 3, 3, 2, 4, 2. These are the ones we want. These values. And then from 4, we go back to 2. And then 2 goes back to 4. So, yeah, so it should be when they're equal to each other, when these two values, it should be when slow and fast are equal to each other. Those are actually the indices. It's really, I think part of the problem might be it should be the evaluation of those indices. Nums. Something like this. It's a little confusing what this is supposed to be. Because there's this like kind of interplay between the indices and the values. They're like kind of the same thing. It gets confusing, but basically you want them to meet at this point, right? So they should be 4 when they meet. Wait, how come? So they're actually both at 2 at the end of this guy. How does that happen? I guess it doesn't really matter. Fast, slow. So they both end up at 2. Oh, that's kind of interesting. How did that happen? Oh. Really? That's not the entry point to the... What? I don't know. That would cause problems, wouldn't it? 1, 2, 3. Oh wow. Huh. So they both start off at 1. And they go, fast goes from 1. Fast goes from 1 to 3. Right, 1, 2, 3 to 2. 1, 3 to 2. And slow goes to 3. Now fast enters this loop. Goes 4, 2. And slow goes to 2. Oh. Interesting. Wow. Well, that's unusual or weird, strange. Oh. Huh. Well. Right. Well, that's really strange. They're not supposed to meet there, if that makes sense. Yeah. Oh, that's really interesting. Huh. How does that happen? Oh, that'll really make your head spin, huh? They hit the same index before they entered the loop, which is not supposed to happen. Which I thought that could happen. But that really only happens when you're dealing with a small loop. Why is that not supposed to happen though? It's definitely not supposed to happen. Huh. I think the issue has to do with the indices, because because here the two values are different. So what's supposed to happen is they're supposed to meet each other at the same index. Yeah, so, well, you could do this. I mean, you could kind of fix this in the following way, but it's not really... confusing as that is. I feel like this shouldn't be so complicated, this program. So if these are on the same, these are the same index, then you return previous slow. If it's not the same index, then it's actually the value itself. Something like this. That's confusing as heck. Oh, come on, really? Oh. What? 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 No. No. What? Why is this so wrong? This is driving me crazy. This is driving me nuts. I don't know, man. It's gotta be my logic somehow. Something's wrong with my logic. It's gotta be. It's gotta be. Oh, no. If the indices are the same. No, but that's never... Oh. No, that's not right. No, this doesn't matter. This is not... I don't know, man. Brain's starting to hurt thinking about this. It's not right. It's not right. So the problem is you can end up in a situation where the pointers meet here, as you would expect, or they meet here because these pointers are represented by indices, and that is so confusing. I already solved it, but it makes me wonder many other potential other solutions, but none of them would be working. Yeah, did you? The solution that we're going for with this one is one that doesn't modify the array, only uses constant extra space, and with linear runtime complexity. With linear time complexity. Brother. What am I doing? Sorry, I'm asking brother. I'm not really asking anybody. I'm asking, practically asking, yeah, just asking the air, not anyone in particular. Because I'm really asking myself, actually. It's just myself. I like this question. I'm really annoyed because I've seen this before. I'm pretty sure I know the answer. I'm not doing it right. Whatever I'm doing it wrong. What? otherwise. What I'm expecting is that they're equal to each other because they both reached the same, what do they call that? They reached the head of the, it should always be, well, that's the thing, is that you can actually, before you even enter the loop, you can end up being equal to each other. That's really the problem. Otherwise, this idea is correct, that you return the, that you return its previous value. What you can do is to guarantee that you're inside the what do they call that? To guarantee that you're inside the loop, you can actually just scroll these forward n times, which is kind of funny. But yeah. Let's do it. Let's do that actually. While n is less than 0, and or yeah, you want to do right. You can do something like this. You're gonna say n is greater than 0, then decrement n. No. Wait. No. You wanna do it n times. So, okay. So while this or n is greater than 0. There you go. And if n is greater than 0, decrement. That's what you want to do. Yeah, so as long as n is greater than 0. So you can do it this way. I think it works. Oh no. Yeah. Oh, it's still wrong. What? This is malarkey. Ah, brother. This is killing me. Why? Alright, hold on. What are we? So, what I'm saying is, these also could just start off at 0, by the way. Why is this happening? Why does this do this? Why? This is so strange. If we just execute, so for I equals 0, I is less than n, increment I, I'm losing my sense of what is happening here. Just run this a bunch of times, so that way you're most definitely inside the oh no, it doesn't work like that. No, because no, the reason it doesn't work. Okay, I think I get it now. I think I understand why. I at least understand why what I'm trying to do doesn't work. Because you do need to start at the beginning of the cycle. It's just fair enough. Yeah. You do need to start at the beginning of the cycle, but the problem is that you could end up in a situation before you even enter the cycle. You know what you need? You need to have This is so difficult. It's just, I don't know. I must be just so wrong. Like, there's got to be something. Like, let's focus on these two cases, right? Let's just get these two cases to work. Let's forget these other ones. There's something very wrong going on here, right? Because I run these two test cases, I run into different problems. Let's just focus on those two, because the other test cases are kind of distracting. One of these works. It seems like whatever I do, one of these works, the other one doesn't, right? So here, 1, 3, 4, 2, 2 works. So somehow this one works, and it doesn't make a lot of sense. It doesn't make a lot of sense to me. So for some reason, this one works. Look at this picture. What is it doing? 0, right? 1, 3. Right, so the fast one goes to 3, slow one goes to 1, fast one goes to 3, 1, 3 goes to 2, and then 4. That's from 3, right? 3 goes to 2, 4, so the fast one is at 4. The slow one is at 3, right? 3 goes to 4. Slow one's 3. Slow one then goes to 2. Fast one goes from 4 to 2. 4 to 2. Back to 4. The fast one's going back and forth between 4. And the slow one goes why don't I just take the previous value to be the fast one? No, well, we'll get to that in a second. All right, so the fast one's at 4, and now the fast one is just 4 every time, and 3 goes to 2. I don't know. 1, 3, yeah, 3 then goes to 2, and the next iteration it ends up at 4. Enters this loop at 4, and exactly when we hit 4, the fast one's looping back and forth between 4 over and over again. And 2 is also, you can't see this, can you? I'm sorry. try to keep that above. Oh yeah, you can see it. And now these meet, and you say, oh, yep, that was when 2 entered the loop, right? Or you entered the loop for the slow one reached. Now, the thing that's interesting about that is inside the loop, this logic is not right. Something here is not right. I know there's a loop somewhere. I'm thinking it should be the 2 nodes literally as soon as you enter the loop. It's actually this node right before these 2 collide. It's also the node right before you enter. However, the slow node, there's a couple things that could happen here. Now, how come somehow my internet hates me anyway? I'm back online. Don't think all the follow-ups can be solved at the same time. I think they can. You got to be clever though. You got to be clever. Although I'm really struggling to do that correctly. Really struggling to do it correctly. So here's a case where the slow node and the fast node. Now, what could happen is the slow node and the fast node could both be looking at index 2. And I think I need to differentiate between the value of the index and I think it's important for me to differentiate between the index and the value at the index. Yeah. Because if I don't do that, then it gets really confusing. They're both pointing to the same index. They'd be pointing at 2. If they both have the same, because they could be both be pointing at this index 4, which is here, or they could be both be pointing at index 2, which is here. The only way they could both be pointing to 4 is if they're inside the loop. But they could be both pointing to 2 if they're both outside. One is outside the loop and one's inside the loop. And that's where things get really confusing, because they're both pointing to 2. 2 is actually the number we're trying to get, so you'd actually have to return one of these pointers, which is not what you're supposed to do. You're actually supposed to return the pointer just before they meet. Basically the slow pointer, the fast pointer should run into the slow pointer. That's pretty much what's supposed to happen. The fast pointer is supposed to run into the slow pointer. However, so really we have to check the indices, right? The indices, you want to know what the indices are. I think and the fast pointer runs into the slow pointer, and the node just before is always going to be the one that we're looking for. The node that points to. which is very confusing. Let's see if we can do that. Let's see if we can try to figure out a way to do that. Differentiate between the indices and the values at the indices. So just do slow index, initially 0, fast index, also 0, right? And we're going to say slow index is going to be updated to, now the slow index, yeah, initially 0. We take this nums of slow index and we actually want slow index is 0. We update it to, so there's 1. So we go 0, 1. So this is the index that we're looking at. It is 1. And then the fast index is going to be this index. So index, slow index is 1. The index is 1, and then fast index, the index is 1, and then we're going to go to the next node, which is 0, 1, 2, 3. So it's 2. So it really is just going to be nums twice. There's got to be a way to like simplify this to understand this, because this is so difficult to understand. So we update them both. Okay. So now we got our pointers. They're moving. They're running. Now we update again our slow index to 1, 3, 1, 1, 2, 3. So here the fast index is it's hard to keep track of it all. Let's actually do it this way. Initially is the indices. Slow is 1, fast is 3, 0, 1, 2, 3. So fast of 1 is here. Slow of 2 is now here. Fast of 1 is 2, which is 0, 1, 2. Fast of, this is the first hop. Which gives us 4. Or we evaluate here, evaluate 0, 1, 2, 3, evaluate 3. Yeah, see, that's the part that's super confusing. It's like there's an evaluation going on. It's like it's just forgive me. Okay. Start off at 0, really. Well, yeah, 0. And then the actual index, these should represent the actual indices, right? So index 0, F0, S0 is index 0. Then S1 is index 3, or 1. S2 is index 3. F1 we ended up at 3. Then F2 we go evaluate 3 to go to 2, 0, 1, 2, and then evaluate 2 to go to 4, 0, 1, 2, 3, 4. That's F2. Now F3 we evaluate here to get 2, and we make the index 2, which is 0, 1, 2, and then we evaluate here to go to index 4, which is right back. So we're going to be back and forth over and over at 2. At some point we have S3, which is evaluates 3 to get to 2, 0, 1, 2. That's S3. How did we get F3 all the way over here? One takes us to 4. 4 takes us to 2. Okay. And then now S3 takes us here. This is S4. And then F4 is 1, 2, F4. And so the indices that we're looking at now are or no, 1, 2, 3. Yeah, it's 4, right? So the indices themselves are at 4. Okay, and they meet there, which is weird because I would expect these not to meet at those indices, but these to meet actually at this juncture, this point, the beginning of the cycle. Why are these meeting over here? Why is that happening? What is going on? What is going on? What is going on? I'm yelling now at the microphone. Sorry. Why? Why? Now I think this has something to do with when the pointers are supposed to bump into each other. That's the wrong index. They're not supposed to bump into each other at 4. Why are they bumping into each other there? If you have nodes and a cycle, they always bump into each other. You have red, 1, 2. Rather, it might just be how I'm coding it. 1, 2, 3, 4. You have green. 1, 2, 3, 4. 5. 1, 2, 3, 4, 5. Oh, I'm sorry. I'm a big dummy. This distance, I'm sorry. I'm totally wrong. Oh, I'm so dumb. This distance and this distance are equal. That's why I keep getting it wrong, even though my math is wrong. Ding! Yeah, I screwed up, man. I keep screwing up. These two distances are equal. Forgot. That's how it works. They don't meet at the site. No, that's not. No, that's not correct. That's not right. Yeah, okay, so we're fine. I was just being really silly with what I was doing. Why am I so human? Why am I so human, you know? If only I could be like the devil and wish I was God. And yeah, alright. I get it now. Okay. Alright, I think I understand what I was doing wrong. So, what you want is then once this happens, you're going to set your slow pointer back to the beginning. And you're going to move the fast and the slow pointer until they meet again. A second time. And this time, they're going to meet at the beginning. And then you want the node right before they meet. That's what I did wrong. I'm sorry. completely mucked that up. Completely mucked that up. So set slow back to the beginning. And now you're going to do while. Same thing. Okay. I hope I'm not doing it all wrong again. Hopefully not doing it all wrong again. Hopefully not doing it all wrong again. Wrong. Still wrong. Oh, this is so wrong. Oh, it's so wrong, it's so wrong, it's so wrong. He's so wrong. Really? Really? Now, there's a few reasons that this could be wrong. So, very close though. Super close. The second one, 6531432. Why is this not working? Why you no work? Why you not do this? Why you not do this? Why is no work? Let's translate this to its cycle, to what it should look like. All right, we got these initial nodes. 0, 1, 2, 3, 4, 5, 6. These are the nodes, and 0 is always at the beginning. We go to 6 as the next node. 2 is here. 6 goes to 2. Or 0 goes to 6, 6 goes to 2, 2 goes to 0, 1, 2 goes to 3. 3, 0, 1, 2, 3, 3 goes back to 1, 3 goes to 1. 1 goes to 0, 1, 5. No. Yeah, this goes to 1, 1 goes to 5. Gets a little confusing, but yeah, 1 goes to 5. 5 goes to 3. Okay. Alrighty. It's pondering that this algorithm would break if you run into a 1 cycle, but the numbers are in range 1 to n, excluding 0, so n 0 is going to point someplace else. If you run into a 1 cycle, something points to itself, but if you run into it, it also means something else points to it, so that place must be the answer. Yes, sir. Absolutely correct. There's at least one node that always has 2 things pointing to it. And that node is exactly the node where the things pointing to it are the duplicates. Right? So it's an issue of finding the cycle. However, if I don't handle it correctly and spend an hour and a half not handling it correctly, then I'm not going to get the answer. Which is great, which is fun. So we have our says 1, 2, 3. Yeah, we have our. Oh yeah, this 4 is just out there on its own, out of the cycle. We don't care about it because it's not. If it's in the right spot, it's not going to end up in our cycle, so we don't care about it anyway. It's not going to be the duplicate. It can't be because. Excuse me. Because if the other number exists somewhere, then it's going to point to it, right? So that's sort of you don't have to worry about that. So alright, so 0, okay, so this looks like our cycle, right? 0 to 6, 6 to 2, 0, 1, 2, 2 to 6 to 2, 2 goes to 3, 3 then goes to 0, 1, 2, 3 goes to 1, 1 goes to 0, 1 to 5, and then 5 goes back to 3, 0, 1, 2, 3, 4, 5, right, okay.
Now, what happens with our pointers? Like, why does our algorithm not work here? So this is the fast one. So 2, 1, 2 goes to 1, say 3 iterations, right? And then 1, 2 goes to 3. And our slow pointer, 1, 2, 3. Okay, interesting. So they both hit. They actually do hit in this case in the beginning, right? Now, what we said was okay, take the. Oh, that's why. I just coded it wrong. Oh, I do that frequently, don't I? Still wrong answer though. What? Wait, what? So we take this, it's 2 pointers, and we now point the green one here, and the red one is here. And now we move them 1 iteration at a time. Actually, let's not use red. Let's use purple. Let's use this. Point them, keep them pointing to where they are. And go 1 iteration here, 2, and 3 iterations. Really until they meet. It should be 1, 1, 1, 2, 2, 3, 3. And they should meet again. But this time we've kept track of the previous value. And now that should be our duplicate. Which seems to be wrong. Which one's the duplicate? 3. No, actually, no, it is the head of the cycle that we're looking for. The entrance to the cycle. Why am I crazy? Am I going nuts? I don't know, man. I'm just out of my mind. There we go. Okay. I think. Oh, man. I just feel silly now. Let's go for it. Let's go for it. Let's see what we do. Oh! This was supposed to be like a 5-minute question, by the way. This is supposed to be like 5 minutes. This should have been like so fast. This should have been like 1, 2, 3. On our way. Oh, brother. Somebody help me. Somebody help me. I need to go lay down for a minute. Just. You know why this took so long? Why is this so wrong? Why it took so long? The reason this took so long, this question. I've seen this question before. I knew the answer, had all the maths, had all the understanding, had all the knowledge. The reason why I did it wrong, and it took me hours to do it, is because 1, I forgot, and 2, I guess I just forgot parts of it. Is because the meeting point inside the cycle is not the beginning of the cycle, not the entry point of the cycle. The meeting is they meet a certain distance away, which actually that distance is exactly the number of nodes before you enter the cycle. So so you actually need to reset the pointer to the beginning, and then where they meet. That's got to be the duplicate node also, because that's the node where 2 things meet. Right? That's got to be where the cycle is. That's also because that has the one that has 2 arrows pointing into it. This is a really cool problem, really interesting problem. I like this problem. It's a super nifty one, super interesting, super fun, but very easy
to program incorrectly and forget how it works and get the wrong answer and freaking take an hour to figure it out. Man, I goofed. I goofed so hard. Ah. I was gonna feel so good about this too. I was gonna be like, boom, like 5 minutes, just 1, 2, 3. I remember this question. I know how to do it. I know what to do. Like, here we go. No, no, not quite, not quite. But yeah, super interesting approach. There is a super interesting approach to this, where you can just realize there's a cycle in there, and then take advantage of that cycle to find the duplicate. Yeah, I like this problem a lot. This is like one of my favorite problems. I've seen this a few times. Yeah, like I said, it's great, but it's it's crazy too, because I did the whole thing you just saw with these two for loops, like that, all that reason, the whole thing, all the reasoning and the loops and all that. I've done it before. Done all of that before. Had this really nice succinct solution. I was like, oh, it's great, it's perfect. And here I am. I just forget about it, and then have to remind myself, and then I code it incorrectly, and then just take hours to do it. Oh boy, it's bad. Yeah, we're at like two almost, I'm approaching 2.5 hours. So yeah, let me go. What I'm going to do is, the plan is to thank God, thank you God for the problem, and for solving it, and for not, I don't know, for being able to appreciate that, and for not being too upset that I couldn't solve it, and not being too upset either that I didn't solve it quickly enough. I guess I didn't remember. How human we are, right? How human we are. Just forgetting things, forgetful. Yeah, let me end this video, this stream, and then start again. Excuse me. And then start again with, wipe my face. Yeah, I'll turn this one off and then start again with a new problem. Man, I thought it was gonna be so clever with this. I thought it was gonna be so. Nope. Because I've seen it before. I was like, I'm gonna knock this out of the park. Nope. Got to remember about the cycles that rabbit in the hare cycle detection. You don't get the head of the node. You get a point that's actually. It's actually, the distance is the number of nodes you have to go from sort of A from the beginning to the head node. That's how many. That's where it meets. The reason for that, by the way, is just like modular arithmetic. It's I sort of, if you meet at some point k, and then you were to subtract from k, like some value, I don't know, we'll call it x, to the beginning, so you subtract, so k minus x, that, and then you consider 2 times k, where you meet at that k, right? So k is sort of the number of iterations that the slow pointer went, and then the 2k is the number of sort of nodes k is the number of iterations, but the number of nodes that the fast pointer went, and then they met. If you subtract x, we'll say that's like going backwards to get to the head node. You would, or even a better way to put it is, actually, I'm not sure how to express it. basically, you know that you've moved 2 times k nodes to meet. And so there's this, some portion of that is looping twice inside, and some portion of that is like the portion on the outside, I guess. And I guess you could say like 2 minus k minus x is got to be equal to, I don't know, I'm sorry, I'm trying to think. How do you do this? Oh man, no, I wish it was really simple to explain. It is pretty simple to explain, it's just I always muck it up. I guess this is probably why I didn't remember it. Slow pointer, fast pointer. Slow pointer gets in, fast pointer actually loops at least once, and then knocks into the slow pointer. And basically, the difference between the slow pointer and the fast pointer has got to be 1 loop in terms of the number of nodes, or some arbitrary number of loops, right? So I guess yeah. No, I don't know. I'm just, oh man, hold on. How do you do this? I'm just thinking, how does the math work on that? It's such a like a, I've thought about it so many times too, and every time I get mixed up. Slow pointer gets to some k, some k iterations. Fast pointer also k iterations, but 2k nodes. Fast pointer just loop around and meet the slow node and the fast node, or the fast pointer and the slow pointer. They meet. Now, why is it that if you move the fast pointer to the beginning and only went 1 node at a time, that the slow pointer and the fast pointer would meet? Right, I think that's the key. Why is that true? Well, the reason for that is if you were to take the slow pointer and increment it again by so there's a portion for the slow pointer and a portion for the fast pointer that's inside the cycle. And in order for the fast pointer to meet up with the slow pointer, those inside portions need to basically be mitigated to nothing, right? So there's sort of this, you could break up that 2k into a certain number of nodes in the beginning, we'll call it z nodes in the beginning, plus some number of cycles, call it, I don't know, ky, or we'll say yeah, 2k is called z plus 2y, and then x would be the amount in the after looping once or twice, the amount where the slow pointer meets, right? Call that x. And the slow pointer, so that's 2k is going to be equal to that sort of z plus 2y, plus z plus ky plus, or not k, we'll call it alpha. Z plus x, z plus alpha y plus x. Excuse me, say it that way, we'll do it that way. All right, so 2k is going to be this formula. And then k is going to be equal to z plus x, right? Because you're going to go with a certain amount of nodes, z nodes out, and then x into the plus also some beta y. We'll call it beta y. Now the problem is if you double. Now if you multiply by 2, this 2k, right? Or rather replace k with this x plus y. So you have 2x plus 2, x plus the z plus x. 2z plus 2x is going to be equal to z plus some, we'll call it still an alpha y plus the part at the end, which is x. So 2z plus 2x is equal to x plus alpha y plus z. Does that make sense? Does that make sense? Yeah. So now, if you subtract, no, hold on, I'm missing something here. Yeah, 2 times k is going to be equal to some x plus some z plus some alpha y, something like that. I'm probably picking my variables wrong, so it's confusing. Let's just do like ABC. Some a, which is the initial portion, some b, some alpha times b, which is like how many times you loop in the cycle, and then some y, some c, which is from the beginning point to the actual point that you meet. 2k is going to be equal to a plus alpha b plus c. K is going to be equal to a plus some, possibly none, b, let's just say none, let's just say a plus c. So you have 2a plus 2c is equal to a plus alpha b plus c. Now you can subtract the a and the c, and you get a plus c is equal to alpha b, right? So alpha's got to be at least non-zero, right? At least positive. And now you're looking for, you want to know what is a. That's what you're looking for. What is a? You find that a, which is that initial part, is equal to alpha b minus c, which is exactly the amount you need to move to get to the beginning, right? Basically, it's a negative. It's negative c modulo b, if that makes sense, which is really confusing. But that's pretty much where that comes from. Is that there's this at least one cycle that has to happen for the fast pointer to reach the slow pointer. It could actually be multiple cycles potentially. I don't actually know. I think it's always one. I think you could probably prove it's always one cycle. But no. Well, I guess if it's a very large cycle or if it's a very short entry point in a very large cycle, then actually could be a very large number of loops that have to be made. Let me just think. No. I think it's only one. I think it's only ever one cycle, because the fast pointer is always going to lap the slow pointer. Slow pointer is only halfway through by the time that, yeah. So it's always one cycle. So it's really just the math. Then is if you have A is the beginning, the nodes at the beginning that open into the cycle, B is the size of the cycle, and C is how far out you go when they meet. So A plus B plus C is going to be equal to 2 times K, and then K is going to be equal to A plus C. Then you can do 2A plus 2C is equal to A plus B plus C, which then gives you 0 equal to B minus A minus C, which then if you want A, you do A is B minus C, which is actually the size of the cycle minus C, which is exactly the number of nodes you need to jump to get to the beginning, right? Which is kind of like negative C modulo B. Yeah. Pretty interesting stuff. Pretty interesting stuff. Excuse me. And right, and obviously you don't need to know the size of B, because all you need to know is that that B minus C is going to be equal to A, and so you could set your pointer at the beginning and go A nodes, and also go B minus C nodes, right? Keep the other pointer at the other spot and move up. That's really insightful. That's a really insightful thing. That extra part where you know what A is with respect to B and C, but you don't know what B is. But you don't care, because you just want to find the entry point where they meet, and so you can just put your nodes, point to both of these nodes, where they met in the first loop, and then in the beginning, and then basically trace them until they meet. Yeah, really pretty clever. Like I said, I'm spending a lot of time on this, thinking about it, but let me go. So thanks again for watching. Talk to you soon. Have a good rest of your day. And I'm actually, what do they call that? I'm actually not going to go. I'm going to just end the stream so that this video is sort of one video, take a break, and then pick up another problem and continue. So.